morning. I am Divya Jyoti, lecturer in computer engineering from Pandit J.R. Government Polytechnic College, Hoshiarpur. Today I am going to present lecture on the topic Introduction to Databases, which is very first topic of the subject Relational Database Management System. In modern society, database and database systems, they have become an essential part of everyday life. Every day, most of us encounter several activities that involve some interaction with the database. For example, we go to a bank to deposit or withdraw funds. If we make a railway reservation or airline reservation or hotel reservation, if we access a computerized library catalog to search for an bibliographic item, if we buy some item online such as a book, a laptop, a toy from an internet vendor through its website, then we come into contact with a database. So let's first explain the very basic concepts which are related to database, and those are data, which is a set of isolated and unrelated raw facts made up of text, numbers, dates, etc. with an implicit meaning. It can be anything, for example, name of a person, it can be a number, it can be image, it can be sound, it can be a date. Any raw fact which has some implicit meaning is called as data. For example, John, which is a name of a person, if a figure or a number 25, a word student, a date, all these are referred to as data. Next term is information. When the data is processed and converted into a meaningful and useful form, it is known as information. So what is information? It is the processed form of data which provides us some useful or meaningful information. For example, we were given data, name of a person John, we were given a number 25, we were given a word student. Now if these facts are combined into a sentence, then they give us information, that is John is 25 years old and he is a student. So this is information. The facts which we were given, they were raw facts, so they were data, and when these facts are converted or processed, they are converted into a meaningful or useful form and give us information. Traditionally, the data was stored in large sized repositories such as files, books, ledgers. However, storing data and retrieving information from these repositories was a time consuming task. But with the development of computers, the problem of information storage and retrieval was resolved. Computers replaced tons of paper, file folders, ledgers, which were used as the primary media or principal media for storing important information. So from the development of computer, we come into contact with a new term, which is database, which is a collection of related data from which users can efficiently and effectively retrieve the desired information. So database is a combination of related data from where we can get desired information according to our requirement. It can be anything from a simple collection of roll numbers, names, addresses and phone numbers of students to a complex collection of sound, images and even video or film clippings. Common examples of non-computerized databases are, for example, a dictionary, a phone book, a collection of recipes, a TV guide or any other manual which is used for a particular equipment. All these are examples of non-computerized databases. And examples of computerized databases include, for example, customer files, employee rosters, online books catalog, equipment inventories, sales transaction record, Google, and your email. From Google is where you can search anything from the database. Your email is also a database. ATM is an example of database system. So from the perspective of an enterprise, we can define database as a collection of related pieces of data representing or capturing the information about a real world enterprise or part of an enterprise to serve the specific data management needs of the enterprise and to support the activities of the enterprise. So an example of such database used in enterprises are, for example, university database. This database stores data about students, faculty, courses, research laboratories, course registration or enrollment, etc., and reflects the state of affairs of the academic aspects of the university. So purpose of using this university database is to keep an accurate track of the academic activities of the university. Here are some examples that use the concept of database, like web indexes, library catalogs, medical records, bank accounts, stock control, personal systems, product catalogs, telephone directories, train timetables, airline bookings, credit card details, student records in colleges or in schools, customer histories, stock market prices, discussion boards. So all these are the examples which today use the concept of database. Different parts of a database are fields, records, queries, and reports. So what are fields? These are basic database storage units, or you can say these are the general elements of content. For example, in MS Excel, you can see here the first column represents a field, the name of a person, John Smith, and you can also say that the field contains a set of characters which have some implicit meaning. Here also an example of various field names which are associated with a person or an employee, like first name of the person, last name or family name, nationality, passport number, date of birth, marital status, occupation, place of issue, valid until. So all these are the fields that represent the main characteristics or main attributes of a particular person. Records are collection of fields. For example, here record is made up of multiple fields like first name, last name, date of birth, address, and social security number. So these 5 fields together make a record, and here we can see that 5 records are present in this table. This is another example of records containing 4 records. Here is an example of a table which is created in MS Access, like it contains the fields ID, date, author, title, body text, and it contains 4 records. When these related records are combined, they create a database file. Next are queries. Queries are the information retrieval request you make to the database. That means the request the user make to the database using some language for retrieving information from the database. Those are called queries. Your queries are all about the information you are trying to gather from the database system. Reports are the data results that your database will deliver as a result of a query. That means after you have executed the query, the result which is shown to you, that is generated as a report. In addition to the storage and retrieval of data, certain other operations that can also be performed on a database, and these operations include adding, deleting, or updating the data. All these operations on a database, they are performed using a software system, that is database management system. So what is DBMS, or database management system? It is an integrated set of programs used to create and maintain a database. If we go to specify or define DBMS in a more precise way, then you can say it is a general purpose software system that facilitates the processes of defining, constructing, manipulating, and sharing databases among various users and applications. Now, by defining a database, we mean specifying the data types, data structures, and constraints for the data which is to be stored in the database. By constructing the database, we mean the process of storing the data itself on some storage medium, like secondary storage medium, that is controlled by the DBMS. Manipulating a database includes various functions like querying the database to retrieve specific data, updating the database to reflect changes, or generating reports from the database. Sharing a database allows multiple users and programs to access the database concurrently. So all defining, constructing, manipulating, and sharing a database, all these are the main purpose of a database management system. Beside these four main purposes, another purpose or function of DBMS is to provide protection and maintenance of the database. Protection includes both system protection against hardware or software malfunction, as well as protection against unauthorized or malicious access to the data. DBMS also must be able to maintain the database by allowing the system to evolve as requirements change over time. That means during time with time requirements of the users change, and we have to make changes in the database. So DBMS must be able to accommodate these changes and maintain the database system. Various examples of DBMS software which are used today, they include Oracle, DB2, Microsoft SQL Server, Microsoft Access, Ingress, PostgreSQL, MySQL. So there are so many examples of DBMS software which are used today. Database system, it's equivalent to database plus DBMS software. So the database and the DBMS software collectively are known as database system. Examples of database systems, for example, we use internet. There we use database systems. For example, many internet websites are driven by database applications like Amazon.com. There we can find book database which allow us browsing books in different categories, for example by author, by title. We can also buy books or any other items online which are also based on the database systems. Another example is purchases from the supermarket. The checkout person scans a barcode of each of the goods, and an application program which uses the barcodes to find the prices in the database reduces the number of such goods in the stock. And if the stock is low, the program places an order for that good. So this is also an example of database system. Purchases with a credit card. Online check if sufficient credit is left on the card, and an application program uses the credit card number, contacts a credit card database, checks if the credit limit is not exceeded, and the application program checks if credit card is not on the list of stolen credit cards, and if purchase is confirmed, the program updates the credit limit. So next is we have discussed this is database management system. What question is why we need this database system? The need of database systems arose in the early 1960s in response to the traditional file processing system. In traditional file processing system, the data is stored in the form of files, and a number of application programs are written by programmers to add, to modify, to delete, and to retrieve data to and from the appropriate files. New application programs are written as and when needed by the organization. So in traditional file processing system, we used to store data in files, and we used to write application program for each operation we want to perform on the particular file. However, this file processing system has a number of disadvantages which are given here. Very first is difficulty in accessing data. There is a need to write a new program to carry out each new task. For example, consider a bookstore that uses a file processing system to keep track of all the available books. The system maintains a file named book to store the information related to books. For example, book title, price, year of publishing, copyright date, category, number of pages, name of the author, name and address of the publisher, and so on. All the information which is related to book. In addition, the system has many application programs that allow users to manipulate the information stored in book file. For example, the system may contain programs to add information about a new book, to modify any existing book information, to print the details of books according to their categories. So for each function the user may perform on the book file, for each function the system has a separate application program. Now suppose a need arises later in time to keep additional information about the publishers of the book. That includes phone number and email ID. To fulfill this need, the system have to create a new file, say publisher, which includes information like name, address, phone number, and email ID of the publishers. So now new application programs are also written and added to the system in order to manipulate the information in the publisher file. As we have written application programs for manipulating the information in book file, in the similar way we have to write new application programs in order to manipulate the information in the publisher file. In this way, as time goes by, more and more files are added to the system, and in addition to that, more and more application programs are added to the system in order to manipulate the information in those new files. So next is data redundancy. Same information may be duplicated in several files. So data redundancy refers to the duplication of data. For example, we have two files, book and publisher. Now in both the files, name and address of the publisher, they are stored. That means there is duplication of the data in both files. So this condition, or this situation is called data redundancy. The data is being duplicated. It leads to wastage of storage space. One is the disadvantage of data redundancy is it leads to wastage of storage space. Another is it increases the duplication of effort. That means if we have to edit the data, then we have to edit those data items which are duplicated at every place where they are written. So the effort is also duplicated along with the duplication of data. Next is data inconsistency, which is the consequence of data redundancy, you can say. The data may not be updated consistently. Suppose a publisher requests for a change in his address. Since the address of the publisher is stored in the file book as well as in the file publisher, so both the files must be updated. But if the address of the publisher is not modified in any one of the two files, then the same publisher will have different addresses in two different files, and this situation is known as data inconsistency. Next problem is integrity problems. In any application, there are certain data integrity rules that need to be maintained. These rules could be in the form of certain conditions or constraints. So these integrity rules are actually, data integrity rules are actually provided for entering valid data into your database. In a file processing system, all these integrity rules need to be explicitly programmed in all the application programs which are using that particular data item. That is, the integrity constraints, they become buried in the program code rather than being stated explicitly. That means the integrity constraints are not defined explicitly or separately in a different file. They are embedded, they are coded in the application programs. For example, the integrity rule that each book should have a book title, it has to be implemented in all the application programs separately that are using the book file. So integrity or forcing integrity constraints is difficult in these systems. Also, it is hard to add new constraints or change existing ones, because when new constraints are to be enforced, all the application programs should be changed accordingly. Every application program, if we want to enforce a new integrity constraint on the data file, then we have to change all the application programs that are using that file. So it is very hard to add new constraints or change the existing ones in case of traditional file processing systems. Another is lacking the relation between programs and data. In file processing system, file structure is actually embedded in the application program itself. Thus, it is difficult to change the structure of the file, as it requires changing all the application programs assessing it. For example, an application program in C++ defines the file structure using the keyword class or struct. Suppose the data type of the field ISBN is changed from string to number, means data type of one of the field is changed from string to number or from one data type to another. Then changes have to be made in all the application programs that are assessing the book file, because in every application program we have embedded the file structure. So to change the file structure, we have to make changes in all the application programs. Data isolation. In file processing systems, multiple files and formats are used. many users are involved in creating files and writing application programs. Therefore, the various files in the system may have different file structures. Moreover, the application programmers may choose different programming languages to write application programs. Handling new queries is difficult since it requires change in the existing application programs or requires a new application program. Lack in security. Application programs are added in an unplanned manner, due to which details of each file are easily available to every other user. That means the file processing system lacks in security feature. So these were the main disadvantages or drawbacks of the traditional file processing system in comparison to the database approach. Apart from these, the main characteristics of the database approach that make this database approach different from the or advantageous from the traditional file processing system are: first is self-describing nature. Now, what is meant by self-describing? Now, database system not only contains the database itself, but it also contains the definition of the database structure, which is called as metadata. You can say metadata is data about data. Definition of the database structure is stored in a file which is called DBMS catalog, and it contains the metadata, or this definition is called metadata. So the database system is self-describing. The definition is stored separately in a catalog, and the application programs are separate. Installation between programs and data. Now, the traditional file system, as we have discussed, that lacks in installation between programs and data because the structure of the files are embedded in the application programs which are using the particular database file. But in case of database approach, as the structure of the database is defined separately in a catalog, and the application programs don't need to be changed if there is a need to change any data item, or there is a need to add any extra data item into the database. So it provides insulation between programs and data. We don't need to change application programs if there is any change in the structure of the database. Support of multiple views of the data. As DBMS provides, or database system provides sharing of data, that means multiple users can use the database concurrently. So DBMS or database approach support multiple views of the data for different users, because different users may require different type of or different views of the database, and this requirement is fulfilled by the database approach. Sharing of data. Multiple users can share the database concurrently, and multi-user transaction processing. And for controlling this sharing of data concurrently, a concurrency control subsystem or module is created in the DBMS. DBMS allows multiple users to access the database at the same time, and multi-user DBMS includes concurrency control software module to ensure the multi-user transaction processing in a controlled manner. That means this concurrency control software ensures that the data is consistent in the database. Advantages of using the DBMS approach: controlled data redundancy, restricting unauthorized access, providing backup and recovery, providing multiple user interfaces, representing complex relationships among data, enforcing integrity constraints, reduced application development time, availability of up-to-date information, flexibility, economies of scale. First of all, controlled data redundancy. As we have discussed, that data redundancy is the major problem with the traditional file processing system, which is overcome by the database approach in a controlled manner. During database design, various files are integrated, and each logical data item is stored at central location. So this centralization of the data eliminates replicating the data item in different files and ensures consistency and saves the storage space. So by centralization of the data items, first of all, the redundancy of data items is reduced, and consistency is maintained, and also the storage space is saved. However, redundancy in the database systems cannot be eliminated completely, because there could be some performance and technical reasons for having some amount of redundancy. However, the DBMS is capable of controlling this redundancy in order to avoid data inconsistencies. Second one is restricting unauthorized access. Since the data is stored centrally, enforcing security constraints is much easier. DBMS ensures that only means of access to the database is through an authorized channel. Hence, data security checks can be carried out whenever access is attempted to sensitive data. To ensure security, DBMS provides security tools like usernames, user codes, and passwords. Different checks can be established for each type of access, like for a user who want to do addition, for a user who want to do modification or deletion into the database, to each piece of information in the database. Next is providing backup and recovery. DBMS includes the backup and recovery subsystem, which is responsible for recovery from hardware as well as software failures. For example, if a system crashes in the middle of a complex update transaction, the recovery subsystem ensures that the database is restored to the state it was in before the transaction started executing, or it resumes the transaction from the point where it was interrupted, so that its effect can be recorded in the database completely. Providing multiple user interfaces. In order to meet the needs of various users having different technical knowledge, DBMS provides different types of interfaces, such as for casual users. We will discuss the various types of DBMS users later. For casual users, query languages are created. For application programmers, programming language interfaces are created. For parametric and standalone users, graphical user interfaces, which will include form style and menu driven interfaces, they are created. A form style interface displays a form to each user, and user interacts using these forms. In menu driven interface, user interaction is through list of options which are called menus. Next advantage of DBMS approach is representing complex relationships among the data. DBMS has the capability to represent a variety of complex relationships among the data, as well as to retrieve and update related data easily and efficiently, which is not possible in case of traditional file processing systems. Enforcing integrity constraints. We have discussed the integrity rules, how they are implemented in traditional file system. In database approach, enforcing data integrity is much easier as compared to traditional file processing system. Various integrity constraints, they are identified by database designer during database design. Some of these data integrity constraints, they can be enforced automatically by the DBMS, and others may have to be checked by the application programs. For example, the simplest type of integrity constraint is specifying a data type for each type of data item. For example, the name of the title of the book must be in characters or in letters, alphabets, or the price must be in numbers. The data type of date must be particular in a particular format. So all these are the simplest types of integrity constraints which can be applied to any database item. Another type of constraint specifies uniqueness on data item values. For example, ID of a or ID of a person, that must be unique, or roll number of a student in a student database must be unique. So these are the simple and very basic integrity constraints which are specified on any database. Next, reduced application development time. The application programmer needs to develop the application programs according to the user's needs. So the other issues like concurrent access, security, data integrity, all these are handled by the DBMS itself. So the application program only need to develop the application program according to the user's need. Other issues are handled by DBMS software. So this makes the application development an easier task for the programmers. Availability of up-to-date information. as soon as one user's update is applied to the database, all other users can immediately see this update. That means the concurrency control subsystem or module uh, ensures this that one if one user is making changes or is updating the database, the other user also is also able to see that or to get those